Okay guys, welcome to this screencast tutorial on how to perform a chi-square analysis in SPSS. As explained in the lecture, this is a test you can use when you have two variables of either the nominal or the ordinal measurement level, but no variable above these measurement levels. Despite this characteristic, the principle is exactly the same as that of the t-test. So basically what this test does is look at the data you have in your crosstabs and perform a calculation to determine what the chance is that you would find this data if in reality this data was purely if in reality there would be no relationship between the different variables. So let's illustrate this with an example. This dataset, some of you may be familiar with it, is a questionnaire in which people were asked, among other things, whether they've seen a series and the kind of grade they would give the series, and also what their gender was. Now, I might be interested to test the hypothesis that gender is of influence in has an influence in whether you've seen Orange is the New Black or not. The way to do this, since both variables are nominal, with gender male, female, and with whether you've seen Orange is the New Black or not, yes or no. So the chi-square test is a test to use here, and to do this you go to Analyze, Descriptive Statistics, Crosstabs, and you get this screen. Hopefully you're familiar with this from Research Skills 1. You can fill in the variables you want to display at the rows and at the columns. So since we're interested in gender and whether this has any relationship with whether someone has seen the series Orange is the New Black or not, we select gender and Orange is the New Black. Okay, so far nothing different from the usual way to make a crosstab in SPSS, but if you want to perform this chi-square test, go to Statistics, click chi-square, and click Risk. I'll explain why later on. Click Continue. Now with cells, you can click basically all the percentages you're interested in. For now, I'll just click that I want to know the count, so how many participants were in each cell and the expected counts. I click these to illustrate something to you. I click OK. Okay, we get this output. Over here we can see in total there were 49 participants. Here we see the cross tabulation, so 5 males indicated that they've seen Orange is the New Black and 20 females. For no, 10 males and 14 females. So it looks like that in the yes category females are overrepresented. Of course, we've only measured 49 people, so we want to know actually what the chances of finding this data if in reality we were wrong. So we would kind of expect it to be equally distributed. The gender doesn't really influence whether you've seen something or not. Okay, basically we can see that over here. This is the p-value for this particular data set. Now what you can see here is that the chance that we would find this data, so 5, 20, 10, 14 in all of these cells, if in reality gender didn't make a difference on whether you've seen Orange is the New Black or not, is actually 10%. This number is too high. Only below 5% do we kind of take the risk and say, okay, gender does make a difference. But in this case, like I said, 10%. So we have to conclude that this difference is just coincidence. So in reality, females don't indicate more often that they've seen the series. Okay, now let's scroll down a little bit. If you'll remember, I've also clicked the value risk. This will give you this table. It will display the odds ratio for seen orange is the new black and for the different categories. What this tells you is that for the category female, the chance that you'll say, yes, I've seen orange is the new black is 1.3, about 1.4 times higher than that you'll say no. As we can see, it's considerably lower among men. So the risk, you could say, of when you're a male that you've seen orange is the new black is quite lower than that you've not seen it. Well, and we can check this in our table. That's correct. 5 males indicated that yes, they've seen it, and 10 that they didn't see it. So these values kind of make sense. Okay, another thing that's a value of interest is that the value here, which is basically this value divided by this value. So what this tells you here is how much more likely are you to watch Orange is the New Black if you're a male versus if you're a female. So you might say that the risk for males to watch Orange is the New Black is 0.35 times lower than for women to watch Orange is the New Black. Okay, so this is just an indication of, well, actually the size of the effect. Of course, this is all very nice and you can kind of see the direction of the effect. Keep in mind though that you can see it here as well. Like I illustrated, you can already see in this table that, well, males tend to answer that they didn't see it and females tend to answer that they did see it. But that interpreting these kind of values and reporting them only makes sense and is indeed very valuable, but only if this is significant. Otherwise, it's just these are just descriptive statistics, and you can't generalize them to your population. So in this case, this isn't that valuable actually to say something about all males and females in our target group. We can't generalize this safely because there's a 10% chance that we would find these findings. So you could say to find a higher risk for females to indicate that they've seen Orange is the New Black. There's a 10% chance that we would find if in reality we were wrong. Gender doesn't make a difference in viewing Orange is the New Black or not. Since we think 10% is too much of a risk, the chance is just too high that we're wrong. We say, okay, these results are just descriptive, they say nothing about the population. So we've actually found no result for gender and whether you've seen Orange is the New Black.